Welcome everyone. Myself J. Rajnikant, Assistant Professor in CSE, SRKR Engineering College, Bhimavaram. Now, in this, we'll discuss about a topic called X.25 networks in computer networks. The objective of this X.25 network is to learn the fundamental concepts of X.25 networks. Now we'll see introduction to the X.25. X.25 is a protocol suite defined by ITU-T for packet-switched communications over wide area network. It was originally designed for use in 1970s and became very popular in 1980s. Presently, it is used for networks, for ATMs and credit card verification. It allows multiple logical channels to use the same physical line. It also permits data exchange between terminals with different communication speed. So actually it is introduced in 1976. It acts as an interface between host and a packet switching network. It is almost universal on packet switching network and packet switching in ISDN. Now we'll see X.25 network example. So this is the simple network example of X.25. Here we are having different components. So one is DTE and DCE. DTE, data terminal equipment, and DCE, data circuit terminal equipment. X.25 is subscriber network interface protocol. It defines how data terminal equipment DTE communicates with the network to send packets over it using data circuit terminating equipment. It uses virtual circuit approach to packet switching, either switched virtual circuit and permanent virtual circuit approaches. It uses time division to multiplex packets. It describes procedures for establishing, maintaining and terminating connections. Now we'll see the layers of X.25. X.25 will mainly consist of three layers, that is physical layer, data link layer or frame layer. Third one is packet layer or network layer. Now we'll see the physical layer of X.25. It lays out the physical, electrical and functional characteristics that the interface between the computer terminal and the link to the packet switcher node. It uses X.21 physical layer specifications, so that X.21 standards are used. So it provides an interface between data terminal equipment DTE, which is like a station, and data circuit terminating equipment like a node. So here it sees that there will be a reliable transfer of the data across the physical link. So in this the data will be transferred in a sequence of frames. So now we'll see the frame layer or data link layer. It comprises the link access procedures for exchange data over the link. Here the control information for transmission over the link is attached to the packets from the packet layer to form the LAPB frame. Link access procedure balanced. LAPB is a subset of HDLC. The service ensures a bit-oriented, error-free and ordered delivery of frames. So here the different categories of these frames are, we are having three types of frames. One is I frame, which is used to encapsulate packet layer protocol PLP packets from the network layer. S frame, flow and error control in the frame layer. U frame, to set up and disconnect the links between a DTE and DCE. Most common U frame packets are sent asynchronous balanced mode SABM and unnumbered acknowledgement UA or disconnect DISC. So these are the different common packets we are sending in U frame. So now we'll see different phases in frame layer. So the frame layer will consist of three phases. One is link setup, data and control transfer, and link disconnect. Now we'll see link setup. Link between DTE and DCE must be set up before packets from packet layer must be transferred. Either DTE or DCE can set up link by sending a SABM frame. Responding party sends a UA frame to show the link setup, transferring data. After link establishment, DTE and DCE can send and receive network layer packets, data and control using I frame and S frame. Link disconnect. One of the parties can issue a disconnect DISC frame to request disconnect. Other party can answer with a UA frame. So these are the different phases that are carried out in a frame layer. Now we'll see addressing at the frame layer. X.25 being a point-to-point and asynchronous balanced mode, support only two addresses at frame layer. So that is, it uses 6 zeros and 1 for a command issued by the DTE and responses that are coming to the DTE. In the similar way, it uses 6 zeros and 2 ones for the commands issued by the DCE and the responses to the DCE. So here it uses two addresses, two different kinds of addresses. Now we'll see packet layer of X.25 network. This layer defines the format of data packets and the procedures for control and transmission of the data packets. It provides external virtual circuit service. Virtual circuits may be of two types, virtual call and permanent virtual circuit. The virtual call is established dynamically when needed through call setup procedure, and the circuit is relinquished through call clearing procedure. Permanent virtual circuit on the other hand is fixed and network assigned. Network layer in X.25 is called Packet Layer Protocol (PLP). It is responsible for connection establishment, data transfer and connection termination. It is also responsible for creating virtual circuit, negotiating network services between two DTEs. Now we will see some dissimilarities and some features that are varying the frame layer from the packet layer. Frame layer is responsible for connection between DTE and DCE, whereas packet layer is responsible for end-to-end connection, that is DTE to DTE. X.25 uses flow and error control at two levels, between DTE and DCE by frame layer and between two DTEs by the packet layer. So now we'll see virtual circuits in X.25. This is the example of this virtual circuits in X.25 networks. So in X.25 is packet switched virtual circuit network. Virtual circuits created at the network layer, physical layer between DTE and DCE, can carry many virtual circuits at the network layer. Each virtual connection responsible for carrying either data or control information. Logical connection between stations is external virtual circuit. Specific pre-planned route through network is known as internal virtual circuit. Typically one-to-one relationship between external and internal virtual circuit. Now we'll see the logical channel numbers LCNs in X.25 networks. So here there will be a LCNs will be assigned for a transfer of the data between DTA and DCA. So here, for example, this DTA uses this logical channel number 34 and it is used to carry the data from this DTA to DTAB. So now the data will be transferred from this DTE to this DTAB by using logical channel number 88. From this same DTA, another logical channel number 72 assigned. So that LCN is used to for the transfer of data to DTEC. So in that way, there will be different logical channel numbers will be assigned to the same DTEs. So in X.25 virtual circuit identifiers are called logical virtual channel number. Virtual circuit establishment between two DTEs create two LCNs. One defining virtual circuit between a local DTE and a local DCE, and other defining virtual circuit between remote DTE and remote DCE. So in that way, so there will be creation of two LCNs. So one is between local DTE and local DCE, and another one is between remote DTE and remote DCE. Now we'll see user data and protocol control information. So this figure illustrates the relationship between among the levels of X.25. User data are passed down to X.25 level 3, which appends control information as a header and creating a packet. This control information serve several purposes, including identifying by number a particular virtual circuit with which this data is to be associated, providing sequence numbers that can be used for flow and error control on a virtual circuit basis. The entire X.25 packet is then passed down to the LAPB entity, which appends control information at the front and back of the packet, forming a LAPB frame. Again, the control information in the frame is needed for operation for the LAPB protocol. The operation of X.25 packet level is similar to that of HDLC. Each X.25 data packet includes send and receive sequence numbers. The send sequence number is used to number sequentially all outgoing data packets on particular virtual circuit. The receive sequence number is an acknowledgement of packets received on that virtual circuit. So this is the slide. In that way, I have explained before in different levels how X.25 the frame is going to be carried out. The summary of this lecture is to understand about different layers in X.25, to differentiate between DTE and DCE, to understand frame format of X.2p, and to learn the concept of logical channel number. Thank you.